In recent years, the nature of warfare has been transforming before our very eyes. But few truly realize just how deep this transformation runs. Across the vast and scarred landscapes of Eastern Europe, a silent revolution is unfolding. One not led by generals or politicians, but by machines. What was once confined to science fiction is now a tangible, steel reality. Ground-based robots are stepping onto the battlefield, reshaping the very idea of how wars are fought. Yet behind every mechanical movement, every hum of an electric engine, lies a much deeper human story. One about survival, ingenuity, and the desperate search for an advantage in a war that has already demanded too much from both sides. It's no secret that the ongoing conflict between Russia and Ukraine has strained both militaries in unimaginable ways. Troop shortages, exhaustion, and the constant threat of precision drone strikes have turned even holding a kilometer of front line into a grueling and dangerous task. In this brutal environment, armies have increasingly turned to machines, not as mere tools, but as replacements for soldiers in the most perilous roles. Resupply missions under fire, evacuations from no man's land, or reconnaissance in areas swarming with hostile drones. These are no longer human-only operations. Robots are stepping in. And while Ukraine has been leading this evolution, Russia too is trying to catch up, sometimes in ways that reveal just how desperate and uneven this race has become. But to truly understand how these machines came to dominate the battlefield, we must take a step back in time. The roots of today's ground drones stretch all the way to World War II. The Soviet Union experimented with so-called teletanks, armored vehicles remotely controlled from another tank, while Nazi Germany deployed primitive suicide tankettes like the Goliath and Borgward. These early attempts failed largely because the technology of the era simply couldn't support them. Yet even back then, the concept was clear: to remove the human from direct danger while maintaining combat effectiveness. The dream of the battlefield robot was born not from imagination, but from necessity. Fast forward to the modern era, and Russia's first serious attempts at creating combat robots appeared nearly a decade ago. Among them, the Uran series became the centerpiece of Moscow's robotic ambitions. Enormous, heavily armed machines that looked impressive on parade grounds and in propaganda reels. But when tested in real combat, the illusion shattered. According to official military research reports, the Uran 9 robot failed almost every critical test during its deployment in Syria. The control range was barely 300 to 500 meters in urban terrain. The vehicle constantly lost contact with its operators, and its mechanical systems broke down under minimal strain. Even its optics, meant to identify targets, were unreliable and often triggered false alarms. The machine that was meant to embody the future of warfare ended up serving as a cautionary tale of overhyped engineering. And yet, despite these failures, the Uran 9 was still ceremoniously accepted into service, though it never made it to Ukraine's front lines. While Russia showcased bulky prototypes, Ukraine quietly pursued a different path, one built on practicality, innovation, and necessity. Early Ukrainian combat robots, like the Mysliviets or Hunter series, first appeared during the years of positional fighting in Donbass. They were modest in size and design, but they worked. Over time, as the full-scale invasion dragged on, the demand for such technology grew exponentially. By the third year of war, entire companies of robot operators, officially known as Ground Robotic Complexes, GRC units, began to form. Several factors pushed this forward: Ukraine's severe manpower shortages, the immense danger of frontline duty, and a new mindset among commanders who sought not just to resist, but to fundamentally outthink the Russian army. Ukraine's logic was simple yet profound. A smaller army can't outgun a larger one by fighting the same way. To win, it must fight differently.
Protecting soldiers by delegating dangerous tasks to machines wasn't just a tactical move. It became a moral one. In a war where every trained soldier is priceless,
machines became expendable heroes. Each ground drone lost in combat saves human lives, lives that the state now recognizes as not only sacred, but financially invaluable, as compensation for injury or death reaches into millions of hryvnias. This shift didn't happen in isolation. The Ukrainian government has actively encouraged the integration of such technologies. The Ministry of Digital Transformation under Mikhailo Fyodorov announced new incentive systems, combat points that could be earned not only for destroying enemy targets, but also for completing logistical or evacuation missions using robotic systems. Soldiers could then use these accumulated points to request new drones through the Army of Drones initiative. By autumn, this reward system expanded to include ground robots, transforming what was once an experimental idea into a national strategy. And none of this would have been possible without one man, Robert Brovdi, better known by his call sign Madyar. As commander of Ukraine's newly formed drone forces, he redefined how unmanned systems, aerial and ground alike, are used in combat. His plan was straightforward yet visionary: make robotic logistics the backbone of the modern battlefield. Under his leadership, divisions were reorganized into regiments and brigades, with entire battalions dedicated to ground robots. One such unit, the famed K2 Brigade, became the first in the world to form a dedicated battalion of ground complexes. They proudly declared, evacuating the wounded under fire, delivering ammunition to positions watched by enemy drones. Robots now do this instead of humans. Technology saves the lives of our soldiers. What began as a handful of experiments has turned into a revolution, one measured not in prototype numbers, but in lives saved. Yet, as the story unfolds, it becomes clear that these robots do more than just deliver and rescue. They fight, they adapt, and they evolve with every mission. The question now is not whether machines will change warfare, but whether humans are ready for the world they're creating. Stay with us, because in the next part, we'll dive into the heart of this transformation, how these machines fight, how they win, and what happens when war itself begins to think. Subscribe, and don't miss what comes next. Part 2. When the first experimental ground robots rolled out across Ukrainian fields and shattered towns, few could predict how fast they would transform from fragile prototypes into lethal instruments of precision. What began as an improvisation, small, remote-controlled platforms welded together in garages and workshops, soon became one of the defining features of modern warfare.
By 2025, the Ukrainian army was not only deploying hundreds of ground drones, but also structuring full-fledged combat units around them. And these weren't mere support vehicles anymore. They had become hunters, defenders, and rescuers all at once. The K2 Brigade, one of Ukraine's most technologically advanced formations, demonstrated what such machines could truly achieve. Their robotic battalion began with simple missions, resupplying forward positions, bringing ammunition under the constant watch of Russian FPV drones, and evacuating the wounded when human medics couldn't reach them. Over time, these robots learned to fight back. One of the first successful combat operations was recorded on a video that spread rapidly across social networks. A small, tracked robot crept beneath a bridge, spotted movement, 3 Russian soldiers patrolling, and quietly followed them. From the operator's perspective, visible through the robot's camera feed, the entire scene resembled a video game. The small machine trailed its targets with patient precision before detonating its payload. When the smoke cleared, 2 soldiers were down, and a third stood frozen in disbelief before being eliminated by Ukrainian FPV drones that coordinated with the ground unit. It was both surreal and terrifying, a real battlefield blending with digital warfare. Other brigades soon followed suit. Ukrainian soldiers, often engineers by training or hobby, repurposed old weaponry and obsolete parts into modern combat systems. In one extraordinary case, fighters from the 93rd Mechanized Brigade
found a decommissioned Soviet UB-1657 rocket pod, once used on aging jet aircraft, and mounted it onto a ground robot chassis. The result was a self-propelled launcher capable of firing 16 57mm unguided rockets at enemy fortifications. The system was operated remotely through encrypted communication links, often supported by Starlink terminals. The ingenuity of these soldiers was as inspiring as it was symbolic. Where one side relied on bureaucracy and mass production, the other relied on creativity and necessity. Commanders like the one known by the call sign Electric told journalists that the motivation behind such inventions was straightforward: survival. "Every time a machine moves forward instead of a soldier, we save a life," he said. "That's the difference between us and them. We treat our machines as expendable. They treat their men that way." His words resonated deeply across Ukrainian media and defense circles. From Kiev to Kharkiv, from Dnipro to Mykolaiv, workshops buzzed with the sound of welding torches and 3D printers, producing new components for the country's expanding robotic army. Some of the results looked like something straight out of an engineering fantasy.
In one viral operation, Ukrainian fighters turned the explosive warhead of an unexploded Shahed drone, originally launched by Russia, into a kamikaze ground robot. They mounted it on a small tracked platform, drove it remotely toward a Russian position, and returned the gift, as the soldiers joked afterward. The resulting explosion left a crater where the enemy trench once was. These stories spread not as propaganda, but as demonstrations of adaptation, a people learning in real time how to rewrite the rules of war. Ukraine's ground robots were not limited to attack missions. The 1st Separate Medical Battalion conducted one of the most daring rescue operations ever recorded, using a robotic vehicle. A wounded soldier had been trapped for over a month, 33 days, in a zone fully controlled by Russian forces. 6 previous evacuation attempts had failed, and 6 ground drones had been destroyed in the process. On the 7th try, an armored robotic carrier equipped with a protective capsule finally succeeded. During the mission, the robot struck an anti-personnel mine, lost a wheel, but continued moving. Later, it was attacked from the air by a Russian drone, yet the armored capsule protected the wounded man inside. After traveling more than 60 kilometers through mined terrain, the machine returned safely. That single act, machines rescuing humans, became a symbol of the era. For many Ukrainians, it proved that technology could not only destroy, but also save. In parallel, Ukrainian defense engineers began to standardize the production of combat-grade robotic vehicles. One of the most advanced was the Droid T-12.7 model, developed by the Kiev-based company DefDroid and modified by the Ministry of Defense in late 2024. It carried a 12.7mm M2 Browning machine gun and could be controlled via Starlink or LTE, ensuring stable communication even during heavy electronic warfare. The Droid T-12.7 wasn't just a gun on tracks. It was an intelligent, modular system that could be operated by up to 3 people, one driving, one aiming, and one commanding, just like a traditional tank crew. During tests, this division of labor dramatically improved accuracy and situational awareness. In real combat, the system proved devastatingly effective. One incident near Bakhmut demonstrated its potential. Intelligence units of the 5th Assault Brigade received reports of Russian mechanized troops moving through a forest belt at night. A Droid T-12.7 was deployed and positioned in ambush. When a Russian MTLB armored carrier approached, the robot opened fire, damaging its control system and forcing it to veer off course. As the vehicle stopped, the robot circled and unleashed a burst into the troop compartment. Reconnaissance drones later filmed the aftermath, the disabled carrier and the scattered remains of the Russian assault group. For the first time in military history, a fully unmanned ground system had single-handedly destroyed an enemy armored vehicle and its crew. It was a turning point, one that even foreign observers couldn't ignore. Western analysts began describing Ukraine's front line as the laboratory of the future, where every battle contributed data to the evolution of autonomous warfare. Within months, other units adopted similar tactics.
Ground robots began to work in coordinated teams, 2 to 4 machines conducting simultaneous assaults under the supervision of a single control group. To make this possible, command centers were equipped with multiple operator stations in one room, allowing synchronized maneuvers. Soldiers compared the experience to controlling a fleet in a strategy game, but one where every move carried life and death consequences. The Ukrainian General Staff, encouraged by these results, started integrating robotized firing points into defensive plans. These fortifications, equipped with automated turrets like the locally produced Shablia and Olya systems, could maintain defensive fire without human presence. For troops exhausted by months of rotation delays, these positions meant rest, safety, and a chance to fight smarter instead of longer. The idea of robotic strongpoints became official policy by late 2025.
At regular development meetings, senior Ukrainian officers discussed the implementation of automated bunkers, drone interceptors, and ground-based turrets to counter Russian assaults. Although the details remain classified, officials confirmed that the systems would be partially autonomous and integrated with radar and drone surveillance networks. The goal was simple: to reduce human presence at the most dangerous points of contact. After years of relentless shelling and drone warfare, automation was no longer a luxury, it was survival. The emotional cost of this war was also measured in time spent on the front. One story that shocked Ukraine came from soldier and medic Serhiy Tishchenko of the 30th Mechanized Brigade, who spent 471 days continuously in one position near Donetsk. His account painted a haunting picture of underground life: tunnels barely tall enough to crawl through, months spent without standing upright, and the constant psychological toll of living under bombardment. Stories like his underscored why automation wasn't just a military innovation, it was a humanitarian necessity. Machines could endure what humans could not. By late 2025, Ukrainian engineers took yet another step. They began deploying recovery robots, machines designed to evacuate other machines. In the 93rd Brigade, modified GRCs were equipped with mechanical arms and towing systems capable of retrieving damaged drones and robotic platforms from the battlefield. Soldiers joked that robots now rescue robots, but the implication was profound. Each rescued unit saved resources, time, and money, turning the Ukrainian front into an ecosystem of self-sustaining machines. Across the lines, Russia was also experimenting, though with mixed results. The Russian Ministry of Defense unveiled its own robotic system, the RTK Courier, boasting fiber-optic control cables and improved image quality. The design solved some communication problems, but at the cost of flexibility. In the absence of aerial relays and with severe shortages of trained operators, most of these machines never left testing grounds. In some Russian units, absurd scenes played out: soldiers walking ahead of their expensive robotic vehicles to trigger mines or draw fire, effectively acting as human shields for machines. Ukrainian commentators described it bitterly as the Russian doctrine in its purest form: men before metal. The gap between the two sides became more than technological, it became philosophical. In Ukraine, robots were seen as protectors, extensions of human intelligence. In Russia, they remained curiosities, limited by fear of innovation and rigid command structures. Yet even this imbalance could shift if Ukraine ever slowed its progress. Every successful Ukrainian invention risked imitation. Russian engineers were already studying captured GRCs, attempting to reverse engineer them. For Ukraine, maintaining the lead was a matter of survival. And so, as 2025 drew to a close, a new front of the war emerged, not between trenches, but between circuits and processors, between human will and artificial precision. The machines of Ukraine had begun as silent helpers. Now, they had become warriors. And as their steel treads carved through the mud of the Donbass, one truth became undeniable. The war of the future had already begun, and it was no longer fought by men alone. Stay with us, because in the final part, we'll explore what this transformation means, not only for the battlefield today, but for the wars of tomorrow.
Subscribe and keep watching, because what's coming next will redefine everything we know about the limits of human and machine. Part 3. As dawn breaks over the battered eastern plains of Ukraine, the air no longer hums with the same sounds of war that once defined the early years of the invasion. The artillery thunders less frequently, and the once familiar roar of tanks has been replaced by something subtler: the mechanical whir of engines without drivers, the low buzz of control systems, and the faint signal tones of encrypted transmissions between operators miles away from the front. What is happening across these scarred landscapes is nothing short of historic. The battlefield itself is being rewritten in real time. For the first time in modern warfare, the front line is increasingly maintained not by men, but by machines guided by human will from a distance.
It is a silent revolution, born of desperation and genius. And it is altering not only how wars are fought, but how soldiers themselves are defined. Reports from various Ukrainian brigades paint a striking picture of adaptation and relentless innovation. The 3rd Assault Brigade, one of the Army's elite formations, has spent months testing advanced versions of their ground robotic systems, nicknamed Droid T-12.7, after the heavy machine gun they carry. These machines are no longer confined to resupply or support missions. They now actively hold positions, patrol intersections, and respond to enemy movement. One such robot, deployed in a destroyed village west of Bakhmut, managed to defend its assigned sector for nearly 6 weeks without a single human setting foot on the front line. Operators stationed several kilometers away guided it through its daily routine, rolling out at dawn, scanning the ruins for signs of movement, and opening fire when sensors detected heat or motion. Each evening, the robot returned to a hidden shelter for maintenance and recharging. For human soldiers, such work would have been intolerable. Endless exposure, constant threat, psychological exhaustion. For the robot, it was routine. The men controlling it described it almost affectionately, saying, "It never complains, never tires, and always comes back." Yet this quiet, mechanical persistence hides a deeper truth about the changing philosophy of warfare. The aim is no longer just to destroy the enemy, but to preserve one's own. The commanders overseeing Ukraine's robotic divisions speak openly about this shift. "We are learning to fight while keeping our soldiers alive," said Colonel Dmytro Kovalenko, head of a drone integration program in Dnipro. "Every time a robot goes forward, that's one less family losing the son." His words echo across the military establishment, signaling a moral and strategic transformation. It is not merely about efficiency, it is about humanity reclaiming space from the inhumanity of war through technology. Still, the machines themselves are not infallible. They are ambushed, jammed, and destroyed. Russian forces have learned to deploy aerial FPV drones as hunters, targeting Ukrainian ground robots in ambushes. The duels between flying and rolling machines have become a grim form of mechanical chess. In one recent encounter near Avdiivka, an unmanned Ukrainian supply vehicle was caught on video dodging an incoming Russian FPV drone, taking cover beneath the remains of a bridge, and then continuing its mission despite losing part of its armor. What astonished observers was not only the robot's endurance, but the coordination between human operators and their creation, decisions made in milliseconds, reactions mirroring those of a living fighter. Such moments blur the line between man and machine, suggesting that the future battlefield will be a seamless hybrid of both. Even as these technologies evolve, Ukraine's innovation extends beyond the machines themselves. In the city of Lviv, a growing network of small defense startups now works hand in hand with the military to prototype, test, and deploy robotic systems within weeks. University laboratories have become miniature arsenals of code and mechanics, where students design modular platforms adaptable for transport, reconnaissance, or attack. These grassroots initiatives, supported by the Ministry of Digital Transformation,
embody a wartime Silicon Valley ethos: fast, decentralized, and relentlessly practical. The result is a level of responsiveness that large military bureaucracies in other countries can only envy. Within days of identifying a new battlefield need, Ukrainian engineers can 3D print components, assemble a new platform, and deploy it under real combat conditions. Every success story feeds back into the cycle, improving the next generation of machines. Among the most ambitious projects discussed in Kiev's defense circles is the concept of robotic strongholds. These are semi-autonomous fortifications equipped with automated turrets, surveillance systems, and integrated electronic warfare units capable of jamming Russian drones. Each stronghold is designed to operate with minimal human oversight for extended periods, allowing exhausted troops to rotate out while maintaining continuous defense.
According to reports from the General Staff, prototypes have already been tested along key defensive lines near Kramatorsk and Toretsk. The implications are enormous. Instead of sending soldiers to man trenches for months on end, entire sections of the front could soon be guarded by robotic systems, networked into command grids, and capable of returning fire automatically when engaged. The psychological impact of this transformation is already visible among Ukrainian troops. Soldiers who once faced the unbearable pressure of constant exposure now find relief in the knowledge that machines are sharing the burden. Veterans describe the shift as a breath of sanity after years of attrition. One operator, known by his call sign, Bison, told reporters, "It's strange. You sit in a shelter kilometers away, moving a joystick, watching through a camera, and yet you still feel the same heartbeat, the same adrenaline. But when it's over, you realize you're alive. You didn't have to crawl through that mud." That's the gift these machines give us. For many, this gift means more than survival. It means the ability to keep fighting without losing their humanity. Even beyond the battlefield, the ripple effects of robotic warfare are being felt in Ukrainian society. Training schools have opened in cities like Dnipro and Kharkiv, teaching young volunteers how to operate, repair, and program these machines. Former IT specialists, engineers, and even gamers have found themselves at the center of this new military culture. The skill set once associated with video games, coordination, fast decision-making, spatial awareness, has become a crucial asset. Instructors often joke that Call of Duty is now a job requirement. But beneath the humor lies a truth. War has become digital in both form and spirit. Meanwhile, on the Russian side, adaptation remains slower. Despite publicized projects such as the Marker and Courier robotic systems, deployment remains limited to controlled environments or propaganda showcases. Russian soldiers in the field continue to face shortages of both equipment and initiative, often improvising with crude modifications that pale in comparison to Ukraine's adaptive engineering. There are confirmed cases of Russian troops using basic remote control systems to push small explosives toward Ukrainian lines, but without reliable communication infrastructure, these efforts have largely failed. Ukrainian analysts note that Russia's top-down command structure hampers experimentation, a flaw that Ukraine's decentralized innovation model avoids entirely. Still, the arms race in robotics is accelerating. Western defense observers warn that what is happening in Ukraine today will influence global military doctrines for decades to come. From Washington to Berlin, from London to Warsaw, analysts are studying Ukrainian battle footage, dissecting every success and failure. The lessons learned here could shape NATO's next generation of autonomous systems. Some experts even predict that by 2030, every modern army will include dedicated robotic battalions, modeled after Ukraine's pioneering example. The war, tragic as it is, has become a proving ground for the technologies of the 21st century. At the same time, ethical questions are beginning to surface. If machines can kill independently, who bears responsibility? What happens when artificial intelligence begins to make tactical decisions faster than human oversight allows? For now, Ukrainian officials insist that all lethal systems remain under human control. But the temptation to automate further grows with every loss,
every casualty avoided through mechanical intervention. Military ethicists and engineers alike are grappling with this balance. How to protect life without surrendering moral accountability to algorithms. In Kiev, conferences on responsible autonomy are becoming as common as weapons exhibitions. The debate is no longer theoretical, it is urgent and immediate. Yet, despite the philosophical dilemmas, one thing is clear. The integration of robotics has already saved thousands of lives. Whether evacuating the wounded from mined roads, delivering ammunition through fields watched by enemy drones, or ambushing armored convoys at night, these machines have redefined the meaning of bravery. They have turned engineering into a form of heroism. In many ways, they have restored hope to a war-weary nation that refuses to break. The broader world watches with awe and apprehension. Ukraine, through necessity and courage, has become the testing ground for the future of war. The machines rolling across its fields today are prototypes of what every army will someday rely on. They carry no emotions, no fear, but behind every one of them stands a human, a programmer, a soldier, a family, a nation determined to survive. The steel and code that drive them are more than technology. They are an embodiment of human resilience. As the war enters its next phase, one cannot help but feel that the line between man and machine will continue to blur. Robots now fight, rescue, and repair each other. They learn, adapt, and evolve. The question is no longer whether they can replace humans on the battlefield, but whether humanity can control the pace of what it has created. Ukraine's example shows both the promise and the peril of this new age. An age where courage is measured not only in blood, but in bytes. And so, as we look ahead, one truth remains. The war of the future has already arrived.
It is being written in the mud of the Donbass, in the workshops of Lviv, in the data servers of Kiev, and in the minds of those who dare to believe that machines can protect what humans cannot. The robots are no longer coming. They are here. And the story of how they are changing everything, from the nature of combat to the essence of survival, is only beginning. Subscribe, stay with us, and remember, what we witness today will shape the wars, the technologies, and the choices of tomorrow.